Here we go. 6E. We are now solving rates. So you learned ratios. We learned how to use ratios to solve problems. Rates is very similar. The difference is that rates usually are in different units. See, like, for example, in this case here, it says that Joanne in example 1 can type 80 words per minute. Okay, so for every minute, Joanne's able to type 80 words, assuming this is consistent throughout and doesn't get fatigued or tired. So the question is then, how many words can Joanne type in 25 minutes if we know her rate is 80 words per minute? How many words can she type in 25 minutes? What do we do? Fraser.
80 times 25.
Beautiful, because it's for every 1 minute, it's 80 words. So if we have 25 of those minutes, which ends up being 25 of those lots, the rate is a very similar ratio. It's kind of like 80 to 1. And what we can see is then, therefore, the other side, if we're timesing the right-hand side by 25, then we also times the left-hand side by 25 to keep the rate the same. And then 80 times 25, and then the way I sort of help you to break it up is forget about the 0, because anything with a 0 is like timesing 10. So you're trying to think of 25 times 8. Some of you might still find that a bit hard, so we break it apart. 8 is broken up to 4 times 2. So let's do this bit. Most people know what 25 times 4 is. 100. Then you times it by 2. 200. So if I wanted 80, for this to be 80, I just need to times it by 10 to make 80. So at the end, if I times it by 10, what's the answer? 2,000. Very good. So 2,000 words is the expected amount in 25 minutes. Obviously, this we do not take into account that she might get tired, get distracted. We're assuming that there's full concentration for 25 minutes straight. Okay? So that was a pretty nice and easy one. Then we move on to example 2. So example 2 now, sometimes they don't give it to you per minute. Per minute's nice because then you can convert it to any other number you want. Sometimes they'll give it to you in ones that aren't familiar. They might say every 2.5 minutes or every 3.4 minutes. And you have to learn to be used to the idea that it doesn't have to be per minute. Okay? But in terms of writing rates, we always write it per something. Per kilogram, per dollar, per unit. Okay? That's the simplest form of a rate. So let's have a look at example 2 now. Example 2 says, a hot dog vendor sells on average 60 hot dogs for every 20 minutes. Okay, so this still works out nicely because the numbers I've chosen are pretty nice. So the question is, how long is it likely to take to sell 210 hot dogs? Yes, Harrison.
70 minutes.
Okay, so your answer is 70 minutes. So let's go through if this is true. So Harrison's got 70 minutes. Let's break it apart. So we start off with our rate. The rate says 60 hot dogs for every 20 minutes. So this is 60 hot dogs per 20 minutes. It's useful to usually simplify it to the simplest rate. So this is not the simplest rate. Simplest rate is if you have it per something. So in this case, I would want it per minute. So how do I convert from 20 minutes to per minute, meaning per 1 minute? What would you have to do? Divide by 20. And that's what I mean. It doesn't, even if this was 3.4, to convert it to this, you just divide what you see here. So if that's 20, divide 20. If this is 3.4, divide by 3.4. Okay? Most likely the numbers we give you are going to be nice. They're going to be nice numbers. So that you can do it by hand because you don't have a calculator on the test. So here I would divide by 20, and sometimes you don't have to even divide it by 20. Sometimes you could be creative. You could divide it into tens and go from tens to hundreds or something like that. So an example would be something like, say I gave you a rate that was per 30 minutes, and I want you to work out for 40 minutes, right? You don't have to convert 30 down to 1 and then go back to 40. You could convert this down to 10 and then go back to 40. Does that make sense? Why have I confused you? Yeah, so what I'm trying to say is when you calculate, you don't have to go all the way down to per minute. and then per every 1 times by 40 to get there. You could actually just go from 30 to every 10 minutes. Just divide by 3. So 30 divided by 3 gets you 10, and then 10 fits nicely in 40. So then you times it by 4 rather than times 40. Yeah, so sometimes you got to be creative with which parts you can try to fit. So that's where the problem solving comes in. But for most of your questions in your textbook, it's pretty straightforward to just convert it back to the simplest form. So yes, we will divide the right-hand side by 20, then therefore you divide the left-hand side by 20 to keep the rate the same. 60 hot dogs divided by 20 gives me how many hot dogs? 3. So we know that their simplest rate is 3 hot dogs for every minute. So the question though, why don't I do it for 3 hot dogs per minute? Is because the question was asking $210. 210 hot dogs. How long does it take? You can go from this step to then go to 210 because it fits nicely. Usually, though, it might be better to convert it into, for 1 hot dog, how long does it take? Okay, so it depends on how you want to change it. If you wanted to change per hot dog, you divide it by 60 to get 1 hot dog per minute. Okay, or per whatever minutes. So it's up to you which one is sort of better for you. In my case here, it does work out nicely. 3 does fit into 210, and how many 3s will fit into 210? 70, and that's where what Harrison had said before was correct. We know that 3 times 70 does give you 210, which works out nicely that 1 times 70 does give you the answer of 70 minutes is how long it will take to sell 210 hot dogs. Again, assuming that there's no downtime in the sales, that it's always consistently the same rate, that's always going to be 3 hot dogs per minute. Okay? So in this case, yes, the answer is true. It is 17 minutes, and that's where you just have to be creative with how you change the rates to what works for you. But the way I'm writing it, that's what rates look like, but you could have converted to ratios as well. You could have done 60 to 20, and therefore 1 is 3, and then 210 to 70. It's the same concept. Okay, you can do it all for fractions or ratios or rates. Rates is nice because you keep the units in front of you, so you know which units or what numbers represent what. Ratio is harder to tell what the numbers represent. Okay? All right, team. So those were the 2 easy or approachable questions from 6E. If you were to do it this way, it would have been the other way. It would have been for each hot dog, it would have been 1/3 of a minute because you would have divided 20 by 60 and it would have been 1/3 of a minute. But that's only if you wanted to do it that way. Okay? Now, what I'm interested is, on the next page, the last example. Most students find this tricky on the test. And I've already guided you with my suggested solutions. I'm going to give you about 3 minutes and I want you to have a go yourself first. Okay, so I'll read the example to you, flip over the page, and I've given you a guide. So the guide should be able to get you to solve the problem. Usually I don't give a guide and then students will struggle with this step. So I'll read out the problem to you. There are 2 hoses used to fill a large swimming pool. Okay, so you've got a pool in the backyard, but you've got 2 hoses. The first hose takes 100 hours to fill the pool normally by itself. The second hose will take 150 hours to fill the pool by itself. But what if I turned off both hoses and I put into the pool? How long would it take to fill that swimming pool? That's usually the typical question. Okay, and usually students then get confused on what to do. But I've given you a sort of guidance. Try to do it in 3 minutes. See if you can follow my guidance, or you don't need to use my guidance and figure out another way. There is a lot quicker way to do this, but this is the most intuitive way to get there. Okay, so I'm going to pause the video for 3 minutes. See if you can figure out the most logical way to answer this. Let's start again. Okay, so hopefully you had a go and had a bit of thinking about it. So this kind of problem doesn't just apply to hoses. It can be like the typical builder thing where if it takes 1 painter to paint a room in, say, 6 hours, and then you hired another painter, so you got 2 painters, How long does it take if they do it together? That's a typical type work-related question. So how do you work this one out? To work it out, the problem is that they're doing it at different rates. One is doing it a lot faster and one is doing it a lot slower. That's why when you calculate, it feels weird to add them together. So what you need to do is you have to look at it in terms of either a pattern, and then I'll show you a quicker way to do it. So the pattern is, for the first hose,
100. 100. So keep adding the hose to this one.
just needing you to focus. Thank you. All right. Yes, you're right. So for the first hose, it's 100 hours. 100 hours to fill up one pool. But if I use that same hose, it can technically fill 2 pools. Boys, you don't have to be disrespectful while I'm teaching. That's your choice. So I already said, let's start. Let's write notes. If you already understood the problem, keep quiet. Be respectful while other people are listening. But when you feel the need to speak while I'm speaking, I just find that, like, why? Why do you have to do that? That's a choice you made. So just reflect upon that. So one pool takes 100 hours for the hose, but then if I had 2 pools, then you would have told me it's 200 hours. Then if we follow that pattern, we see that it's 300, 400, 500 hours for 5 pools. And if we look at the second hose, it starts off with 151 pool, so that means the next one is another 150, so it makes it 300, then 450, then 600, then 750, etc. Right? But what we start to see is that at some point, there is somewhere that we can compare the rates, because right now the rates are totally different. The rates are the same when we can see that at 300 hours, so at the same time frame, there's something definitive. For both of them, we can say for one, the hose number 1, it can fill 3 pools. So in 300 hours, hose number 1 does 3 pools. And in the same time, hose 2 can do it in 2 pools. So that means if I ask you at 300 hours, how many pools can actually be filled, we can say the rate is at 300 hours, there's a total of 5 pools. This is your new rate. This is the rate that you can see that. So the rate together is that it's in 300 hours, how many pools you can do. So you can do 5 pools per 300 hours together. Because we clearly can see at 300, hose 1 is 3 pools. At 300, hose 2 is 2 pools. So together, it must be 5 pools per 300 hours. This is the combined rate. So now that we've got the combined rate, we can then convert this into the simplest form. So if I want to know how many pools it can fill per hour from 300 down to 1, how do I go from 300 down to 1? Divided by 300. Whoops. So in this case here, I would divide this by 300 on one side, and the other side, I'd also divide it by 300 to simplify that fraction. So 5 divided 300 is the same thing as writing 5 over 300 of a pool. That's how much it can fill with both hoses in. It can fill 5 out of 300 of a pool. But let's simplify that. 5 over 300 can be simplified down to what?
5 over 300.
What number goes into 5 and goes into 300?
5.
5. So how many 5 goes into 5?
1.
What?
1.
1. So it goes 1, and how many 5 goes into 300? 60. So what this means is every hour with 2 of those hoses together, you fill 1/60th of the pool. So if you cut it into 60s, 1/60th of a pool per hour. So how long does it take to fill up one pool? I need 60 of these. 60 hours. There we go. So, logically, if you want one pool, you need to multiply this by 60 to make it one pool, because that's 1/60th. Yeah, it's 1 out of 60. So you need 60 of them to make one whole. So you need to times this by 60, and naturally then you know you need 60 hours. So now you know you don't have to keep checking every half. Don't throw things in my classroom. No. I don't need pointing. I don't need none of that. You see, like when I see this, see that? This doesn't come out of nowhere. See this one? Doesn't come out of nowhere. See this one? Doesn't come out of nowhere. And then when you guys point at each other and go, oh, he did this, he did that. I don't care. Stop doing it. It's disrespectful. I'm teaching. If you didn't want to be here, get out. Go somewhere else. Do something else that's more beneficial for your life that you think this is a waste of time. I'm not stopping you. Do it. Get out of here. But you choose to be in my classroom. You choose for me to tick off your name saying that you're present in my class because you want to be here. And I've done you that favor. I've ticked it off. Your parents are happy. But why are you here if you don't want to be here? Stop doing it. That's what I mean by being disrespectful. Because you guys chose to be here. And I always do you a favor when I tick off your name. That's a big favor on my part to you. Because when I do that, your parents are happy. They're not hassling you. They're looking at the role going, oh yeah, my kid's learning. But are you learning? That's up to you. So when I tick off your name, that's me doing a huge thing for you. So when you do this, that's disrespect to me. Because I could have marked you absent or could have sent you to middle school, and by the time you get home, your parents can have a chat with you and you can have a chat with middle school. Because I ticked your name off. You can walk home today doing nothing in my class at all or anyone else's class, and your parents have no clue. That's the benefit of each teacher ticking off your name. That's what it means. You can walk to class and just breathe, and you won't get in trouble. That's the system you guys live in. That's why I get pissed. If you don't want to learn, just sit there. I'll pick that up and throw it in the bin later. All right, so we had one pool per 60 hours, and that was one way of doing it. So that was one way to look at the common rate or common time. But there was a quicker way, and there's formulas for it. For me, the logic was here. First one was 100 hours per pool. So if you actually wrote it out, it's actually 100 hours per pool. And you can think of it as like it's one pool per 100 hours. But that's as a rate. If you write it as a ratio, it looks like this. 1 to 100. If you write it as a fraction, it actually looks like this. That's what you're doing. That 1 represents number of pools. That 100 represents number of hours. Why can't you add this one with the other one? Because this one now means for one pool, it's 150 hours. And we know with fractions, different denominators means they're different rates or different items. You can't add them. But what you can do is use what you've learned in chapter 3. You can add them when they have the same rate or same denominator. This is where you look for LCMs. 100 and 150 is pretty much what this table was doing. This table was helping you to see lowest common multiple. So hundreds and 150, I knew times this by 3, times this by 3, you get 3 over 300. Plus, times this by 2, you get the 300. Times this by 2, and you get 2 over 300. Now you can add the fractions. Fractions together becomes 3 plus 2, which is 5 over 300. And the meaning is 5 pools for every 300 hours. And that's how you get your rate quicker for the combined one. Yep. Yep. Okay, so that's another way of doing it. And if you simplified that fraction, you would have got 1 over 60. So 1 pool per 60 hours. Yep. Yep. So you have so now that I've finished that was the last example, and that's as hard as it gets. Okay, in terms of rates, your job to revise chapter 3, decimals, percentages, and fractions. Those are your core. So next week in week 9, probably either midweek, maybe the last session, so on the Thursday is when we'll do the test. That way I'll try to mark ASAP to get most of your reports done by the end of week 9. By week 10, your semester reports will come out to your parents on the very last day, so then I'll have some time to then double check it and check your homework. So you have a bit of time from now until the end of next week to one, revise, but also catch up on any work you're missing. So most of you might be on about 3I, 3J. It's okay. You only got 6A, B, and E. Okay, so just do the fluency if you need to, or work on mainly chapter 3 to be ready for next week's master.
We have to do 6A, B,
In your own time. Or today's lesson, tomorrow's half session, and then we've got Thursdays and weekend. And then next week, Tuesday. Plenty of time. Alright team, I'm going to stop the video.